Now consider the introduction of a complex price floor, P mean, that has the following properties. The policy says that P has to be greater or equal than P mean, and the government buys excess supply at whatever the equilibrium price happens to be, and that is done so that the market clears. Notice that once this is done, one is to worry about two things. One is, where does the revenue for the policy comes from, and we're going to assume an equal lump sum tax. So whatever the revenue that is necessary to pay for that is raised for consumers using an equal per head lump sum tax. Now, why lump sum taxes? Is we know that most taxes are distortionary, because we want to isolate in our study the efficiency cost of the price floor from the efficiency cost of taxation, and if we were to use a non-lump sum tax, we would not know where the source of the inefficiency comes from. That's why we focus on that form of revenue. The other thing that we have to worry about is, once the government is buying its excess units, what happens to the units? To the units bought by government? We are going to assume that they are destroyed. Now, you may think that this is a ridiculous, wasteful, immoral policy. I would agree personally with you. Unfortunately, it's very common, especially in the agricultural realm. So it's not completely unrealistic. So let's see what is the effect of the policy on equilibrium. We have that the market without looks like this: X demand, X supply. And then, of course, this is the P star without the policy, the quantity in equilibrium. Now, a binding price floor gets introduced. It's going to be something like this. Pi mean is going to be binding because the prices cannot go down to their natural equilibrium price. And what we're going to have is that then this becomes the equilibrium price with P mean. And then there are going to be two quantities that are relevant in this complex policy. One is the X star consume. This is the amount that the consumers get to consume, and this is the amount produced. Notice that these two are not the same because the government buys all of these units. So these are bought by government but destroyed. Now let's look at the effects of this complex policy, complex price floor policy on social surplus. Now this one is going to be a little bit more complicated than before, so it's important that you follow every step and rewind if necessary. This is the demand, this is the supply, this is going to be the price floor, the binding price floor. And I'm going to define several areas for you. I'm going to call this A, B, C, D, E, F. This we're looking thing is G, triangle H, triangle I. And as before, I'm going to do a table about what is the consumer surplus, the producer surplus, and the social surplus under three conditions: the market, the binding price floor, and the difference between them. Okay, so let's do it together. The market is just as before. It's going to be A plus B plus E, C plus D plus F, and the sum from A to F. What now becomes more complicated here is what happens with the policy. And remember that this is the amount consumed in equilibrium with the policy, and this is the amount produced. And these are the units bought by the government and destroyed. Okay, so what is consumer surplus? Well, clearly they get to buy all of these units with the efficient rational rule. The consumer surplus is A. But we are not done, because the consumers also need to pay a lump sum tax to finance the purchase of all of these units at the binding price. So we also need to take out minus E plus F plus G plus H plus I. These are the taxes that have to be paid. Okay. Now, what about the producers? The producers get to sell all of these units to the consumer at a price B plus C plus D. Sorry, at the price P mean, they only incur this cost, so they get all of the surplus B plus C plus D. But they also get to sell to the government all of these units at the same price. So they also get the surplus E, producer surplus E plus F plus I, which is the total revenue from those units minus the total cost. So plus E plus F plus I. If you do the sum, you get A plus B plus C plus D minus H plus G. Okay? And if you do the difference for the deadweight loss, you're going to get minus E plus F plus H plus G. So this is the deadweight loss of this policy. Notice that it's bigger than the one we had before, and I'm going to talk about the intuition in a second. What about the producers? Well, the producers are better off by B plus E plus F plus I, and the consumers are worse off by minus B minus B plus F plus G plus H plus I. So this policy is particularly bad for consumers. I hope that you can see that. And it also entails quite a bit of transfer of consumer surplus to producer surplus. Now, what's the intuition for why the deadweight loss is larger in this case than in the previous one? Well, in the previous case, with the deadweight loss was due to the fact that these units from here to the X star were not being produced, and it was socially efficient to do so, so that led to that deadweight loss. But here, in addition of not producing those units, we are producing extra units and throwing them apart. And not only that, the extra units that we are producing, all of these are being thrown away. So that has a cost, which is the cost of not consuming these units and having to pay the cost. And that extra cost is what is showing up there. So this policy is particularly inefficient.